By now, you're probably wondering, why can't we just have one version of all the assets? Well, let's take a look at this page here. So I'm at design.google.com/devices. And this page lists all the popular Android devices. There's some phones, some tablets, and even some watches. But as a note, it doesn't list all the devices. Now, what's useful about this chart is that you can find both the dimensions of the screen in dips, as well as the density of the device. So here we see some HDPIs, some XHDPIs, and some XX HDPIs. As you can tell, there's a huge range of Android devices, and they have different densities. Now, to refresh us about densities, let's take a look over at the Android developer documentation at the topic supporting multiple screens. So down here, for the definition of screen density, it says that density means the number of pixels within the physical area of the screen. And it's usually referred to as DPIs or dots per inch. We have 5 common density buckets that you should be familiar with. An MDPI device, or medium density device, has about 160 dots per inch. An HDPI device, or high density device, has about 240 dots per inch. An XHDPI device, or extra high density device, has about 320 dots per inch. And the number of dots just increase from there. So with the extra high density device, and that's 3 X's, it has about 640 dots per inch. So as the name and numbers indicate, the number of pixels on screens increase as we increase density. So as time has passed, the device hardware has gotten even better. We have even higher resolution devices, meaning more pixels that can fit on the screen than what's shown here. But for now, let's just focus on these 5. So in the last course, we learned about how we can specify the width and height values in density-independent pixels. So that means we can say that a button should be 48 by 48 dips in size. And in reality, Android will translate that number into different numbers of pixels depending on the screen density of the device. So how would that work for something like an image? Well, as a developer, you would declare the width and height of an image to be in dp values, such as 48 dp by 48 dp, for example. Then Android would make sure that all these images appear roughly the same physical size across devices, no matter if it has a small number of pixels per inch or a very large number of pixels per inch. However, if we only have a single version of the image, Android might need to blow up or stretch out the image for higher density devices, which have more pixels on the screen. Or on the other hand, if we have a version of the image with a lot of pixels, Android might need to do the extra step of shrinking it down for lower density devices. And either way, the image might end up looking distorted or blurry, and that is not what we want. So we can solve this problem by providing different sized versions of the same image for each of the density buckets. And this will allow us to have crisp images on all devices without causing the Android device to do too much stretching or shrinking of the image while the app is running. So to know what size assets the designer should provide, there are DP to pixel conversion ratios. For a medium density device, 1 dp equals 1 pixel. So if we want the image to be 48 dps by 48 dp in size, then the MDPI version of the image should be 48 pixels by 48 pixels in size. Now for high density devices, 1 dp equals 1.5 pixels. So if we want the image to be 48 dps by 48 dps in size, then the HDPI version of the image should be 72 pixels by 72 pixels in size. We can repeat similar calculations for high resolutions using the provided ratios. And as you can see here, the XXX HDPI version of the image will be a lot larger than the MDPI version. But that's because the XXX HDPI device has a lot more pixels on its screen. So in the end, all these images will appear the same physical size to the user on their respective devices. Now let's take a closer look at the pixel size of the images we provided you. So let's jump into the drawable-MDPI folder. I'm going to take a look at the sun image. So I'm going to select it, right-click, and get info. Now here, for the MDPI version of this image, we see that the dimension is 88 by 88 pixels. So we'll be showing this image as 88 dp by 88 dp in the final app. So the size of this version has to be 88 pixels by 88 pixels, since 1 dp equals 1 pixel on an MDPI device. So what does the pixel size look like for a XXX HDPI version of the same image? So I'm going to navigate to drawable-XXX HDPI, find the sun image, select it, and also get info. So we find the image here is much larger, and it's verified by the dimensions listed here as 352 by 352 pixels. So what we're doing here is making a trade-off between the amount of storage space that our app will need and the amount of processing power it will need. So when we provide multiple versions of an asset, the app does take up more storage space, but it uses less processing power. And remember, for mobile devices, that's a really useful trade to make because it means our app will run on less powerful devices without running into performance issues. All right, now we understand why there are different assets at different sizes in different folders. So go ahead and add all these images to your app. Copy over each drawable folder and then add it to the res directory of our app in Android Studio. So here in Android Studio, we see that all the MDPI versions of the images are in the drawable-MDPI folder. Same for the HDPI folder, so all the HDPI images are here, and for all the other resolutions as well. Once you're done making these additions to the res directory, your app should have these 5 new folders. All right, so now that you understand why there are assets at different sizes in different folders, I'd like you to go ahead and add all these assets to your app. So copy over each of the drawable folders and add it to the res directory of our app in Android Studio.